entitled Applications of the Integral and Taylor Polynomials. So two important applications of the integral are arc length and surface area. So arc length, we'll start with that. So I'm going to give you the formula. This is pretty important for these problems. So this is a small s, I guess they're saying. So this is your arc length is equal to the integral from a to b of the following. The square root of 1 plus f prime of x squared dx. Okay, so arc length, I should say, of a function, some curve from a to b. This is our interval. Okay, so this is basically measuring kind of what it sounds like. So here's your x and your y, and then let's say you have some function going along, and then you want to measure from a to b. So from a to b, how long, from this point to this point, how long is this arc right here? Okay, that little section of the curve. Okay, so this is the formula that can give you the arc length. And if you are really curious, the proof of this formula is in your textbook, but I don't want to waste your time with that on this video. So that's your formula for arc length. It's pretty important. And then also, the second thing that I mentioned in the application of the integral is something called surface area. So this is denoted by a big S, and then I put these little dashes on it just to differentiate. But okay, so surface area, which is big S, is equal to alright, well actually I'll write out the formula after I explain what's going on. So let's say we have this curve, right? This little arc right here. So we have our x and our y, and then something that goes up and comes down. Okay, so here's our a to b. Okay, so from here to there, right? So we're focusing on this part right here. Okay, so what this is our arc length, the thing that I just kind of made bold, I guess. And then for surface area, what we're going to do with this little section of the curve, forget about this part and this part. Forget about the left and right. We're just focusing on this part right here. What we're going to do is basically spin this curve or rotate it about the x-axis. Okay, so we're going to make like a circular pattern here. So let's take this one point here, this one endpoint at A, and we're going to spin it around the x-axis. Okay, so it's actually going to be like going down this way and then coming up. Right, and we're going to do the same thing with B. So that'll be going down and around. Okay, and then you see how it'll kind of make like a reflection of the curve down here if you were to spin all of these around and make like circles. Okay, so I'm trying my best here. So this is the surface area. We're not taking the solid part. So this is kind of like a hollow shell, all right? And this is the hollow shell that we generate by spinning this arc length, this little section of the curve, around the x-axis. Okay, so for this, as you can see, we're going to have, like, take for example the first circle that I drew from A, this one right in the front. What we're going to be doing, well, the circumference of this circle is actually 2 pi r, right? Because we learned that in, what, geometry or something? 2 pi r, okay? And then, so our r in this case, the distance from the center of the circle, which is the x-axis, to the outer edge, is actually going to be our function, right? This is our f of x, or our y. So r is f of x in this case. And then, so that was just for one circle, right? But we want to integrate we want to add up all of the circumferences, is that a word? Circumferences of all of the circles from this interval from A to B. So our surface area formula is actually going to be 2 pi, and this comes from the circumference formula. And then we're going to integrate from A to B our f of x. So that's like our r, right? And then this takes care of, and this will look familiar from the formula on top, this is the formula for our arc length. Okay, so this portion right here, that takes care of adding up all of the circumferences of the little circles that we're going to be drawing or calculating. Okay, so this is surface area. Surface area. Okay, so yeah, so like I said, the f of x is like our radius, and then this part right here is like our arc length factor. So arc length factor. Okay? Alright, so let's do an example of this. And I'll do a surface area one because those tend to be a little bit more complicated. So let's calculate the surface area of the following. F of x equals square root 4 minus x squared. And then we'll go from negative 1 to 1 for our x. Okay, so let's draw this out real quick just so we can visualize it. So we have our x and our y, x and y, and this is a circle of radius 2. So we have 2 this way, 2 this way. This might not be too accurate, so not drawn to scale necessarily. And this is a positive function, right? It doesn't say plus or minus. It just says, it doesn't say anything, so that implies positive. So it actually looks like, all right, I'm kind of bad at drawing circles, but we are going to try here. Okay, so this is the semicircle, right, on the top half of the x-axis. So this is our curve, except for we also have a boundary here, so from negative 1 to 1. So this circle actually goes from negative 2 to 2. So if we want to go from negative 1 to 1, we're going to have to cut it off right here. So here's our A, and this is our B, right here. Okay, so we're focusing on this little top of the arc here. Okay, so ignore the left and the right, just this little section. So now we want the surface area, so we're going to have to rotate this curve about the x-axis. So let me draw the circles. Okay, rotating down and around, and then this will actually go down the same height. And then it's going to make a reflection of the curve down here, right? And this one's actually going to cross it, negative 2. But anyways, so this is the solid that we're taking the surface area of. Okay, now I'm just drawing the little circle things. Sorry if this doesn't look too pretty, but that's the general idea. So we're going to apply the formula. So we're going to have surface area equals 2 pi from A to B. I'll just rewrite it so you guys are more familiar with it. Times 1 plus f prime of x squared, and then dx. Okay, so we know our f of x, right? That's what we're given. We need to find our f prime of x, so we can plug it in. So f prime of x is going to be, let's see, what do we have here? 1/2, and then we have all of this to the negative 1/2, so that goes on into the bottom, into the denominator. So there's that, and then we have to do chain rule, so that's a negative 2x. Okay, so we end up with a negative x over square root of 4 minus x squared. Okay, so that's our f prime of x. So now we need to plug it into the square root. So now we have, let's see, 1 plus, and then all of that, 4 minus x squared, squared. Okay, so then this is going to equal, we'll rewrite the 1 plus, and then the negative turns positive once you square it. And then that is over 4 minus x squared. And now we'll simplify. So this, we're going to multiply the 1 times 4 minus x squared on top and bottom. So we get 4 minus x squared plus x squared over the common denominator of 4 minus x squared. Okay, and then these on the top cancel out conveniently. The minus x squared and the positive 1. So we can actually take out the 4 on top and it becomes a 2. So, let's see, we end up with something like this. So this is our square root portion right here. This is like our arc length, okay? So now we just plug it into the formula. So I'll do that on the next slide so we can finish the problem cleanly. Okay, so now we get for surface area is, we're going to put it all together now. So 2 pi from negative 1 to 1 And then we have our f of x, which is 4 minus x squared, and then times the arc length thing that I just found and simplified, so that's 2 over 4 minus x squared, and then we have our dx. And then, as you can see, the square roots cancel very conveniently, because we wouldn't want to mess with those. Okay, so our final answer is going, well, not our final answer, our simplified answer now is going to be 4 pi from -1 to 1 of dx, which we all know equals 4 pi x from -1 to 1. And then I'll rewrite it down here. So surface area equals 4 pi 1 minus a -1, and this is just a 2, right? So now our final answer is 8 pi. This is our surface area. Okay?